Okay, I'm super excited about the area of trapezoids lesson because, well, let's face it, trapezoid is just a cool word. And it's got a cool formula, but before we write up the formula, let's derive it. This is one that some people remember and some people don't, so let's see where it comes from. I have got here a parallelogram, but I've got it split into two trapezoids. And the way I split this is I split it so that the trapezoids would be congruent, the shaded trapezoid and the unshaded one. But one had to be turned, so just to make sure we're seeing this the same, my base one is my short base, and I flipped it around, and so it became, instead of sitting on the top, it's now on the bottom. And that, of course, brought base 2 up to the top. So if you look at this overall, the whole thing is a parallelogram. How long is it across the bottom? Well, you have to join the two pieces together. So the full length across there is base 1 combined with base 2, or added together. And then the height is just right here at the right angle hitting the base. So to find the area of the whole parallelogram, I would say just my area formula is to take the length across the bottom, which is my base 1 plus base 2, and multiply that by the height to the other base. And so that's the parallelogram, remember. Now I left a big gap here because I'm trying to get the area of the trapezoid, which I told you these are equal. So this trapezoid here is just half of the area of my parallelogram. Okay, so this is the formula of a trapezoid. Let's go and write that on your formula master sheet. You probably remember this formula or seen it before anyway. The area for a trapezoid is equal to taking just half of the total length of the bases, the combined total of base 1 and base 2, multiplied by the height. Now I've got a couple of diagrams because they are usually shown differently. This is the one you just saw. This is if you have your two bases, top and bottom, which happens a lot. And then the height is measured through hitting both bases at a right angle since they're parallel. This is your height. Hopefully you can read that. But a lot of times you're going to see your trapezoid sitting kind of on its end. So the bases are actually the two left and right sides. This is being base 1 and base 2. And when that happens, often enough, you get your height where the right angle is. If this is a right trapezoid anyway, you get your height running along here. Always check for your right angles. And so let me highlight again. This is my height that connects my two bases and hits both of them at right angles. Same with this one over here. Just think it's good to highlight these on your formula sheet so you're using the right things. All right, let's apply it first to a real problem. This is the state of Nevada, which is very much like a trapezoid. It's not exactly a trapezoid, but we can use a trapezoid to approximate its area. Okay, so here's what I'm thinking. I'm thinking these two bases are right here, this 210 miles and the 520. If anything's parallel there, it's those two. And it's about a right angle at the top here, so the 310, that's my height. Let me label that. All right, so we're just going to plug into the formula. It's half of the base plus the other base, and then multiply by the height. Okay, those parentheses are kind of important. You better put them in there. All right, what are my two bases that I'm going to be adding in here? I'm going to take 210 for one of my bases and 520 for the other one. And then for the height, let's put in the 310. All right, a little arithmetic for us. Let's combine the two bases. That's going to be 730, and then multiplying by 310. So grab a calculator and do that. Okay, I'm getting a grand total, and this is big. This is 113,150. Now it's area. These were in miles. We've got square miles, and that's the approximate area of Nevada. I'm giving a treat to whoever can actually look that up. What's the real area of the state of Nevada? Tell us how close we are. All right, next one's just a typical geometry problem. We're going to find both area and perimeter of the trapezoid. Now I'm noticing that I'm missing this side right here, and I need that for perimeter, and I probably need it for area too. So let's just take care of that right now. Okay, one thing I'm missing from my diagram is that this was a right angle, and that should be correct in your note sheet. So I'm going to draw in a height, but I'm going to do it over here in such a way that I can pull out a right triangle. So let me draw this in. There's the right angle, and let me steal the 4 feet and just transfer it over to here. Okay, so check this out. I have this right triangle. I need to know how long this is, but this is how I'm going to do it. I notice it's 4 and 5, and the 5 is the hypotenuse, so I'm going to say this is a 3-foot side, just using my 3, 4, 5 Pythagorean triple. Now that helps me because this was 9 feet all the way across, and I've just chopped off 3 feet of it. So that means this remaining piece is 6 feet. And then yes, I can put that same 6 feet right up here at the top. Okay, kind of had to work my way around that. Okay, let's do the area. So area, again, is half base 1 plus base 2, and then times by the height. I think it's important to write that formula to keep things straight. Okay, so we're going to be plugging in some numbers. Of course, we're going to have to add right here. What are our distances? Base 1 is 6 feet, base 2 is 9 feet, or switch them around, doesn't really matter. But 6 and 9 are the bases, and then the height is the 4 feet that we had. Okay, let's crank it out. So we've got 1/2. Combining the bases gives me 15 and timesing by 4. And all that multiplied together is going to give me 30. So I have got 30 square feet of area here. Okay, let's wrap it up with perimeter. Perimeter's all the way around. Let's start at the bottom with the 9 and work our way around. 9 plus 4 plus 6 plus 5. We've got all 4 sides in there. Let's add them up. I'm getting 24 feet in perimeter. Oh, my favorite kind of problems. They're real world. Again, this looks like a nice deck. I might have to build one of these this summer. But what's the area of it? Now, we're going to have to do some chopping this into pieces because it's kind of an irregular shape. But they've already got a 20-foot piece here. So I'm looking at this as a trapezoid right here. Let's call this trapezoid number 1. And the reason I want to call it number 1 is because I'm going to draw that same 20-foot distance right here. And I've got another trapezoid on this end, and we're going to call that trapezoid number 2. Just leaves me a nice rectangle in the middle. So in order to figure out this area, here's my plan. I'm going to take trapezoid number 1. I'm going to add trapezoid number 2. Hope you understand my abbreviations here. And then I'm going to add in the rectangle that's in the middle. Okay, so let's tackle trapezoid number 1. Now this is one of those typical with it on the side. There's my right angles. My bases are running up and down, and 10 feet is the distance between them as my height. So for trapezoid number 1, let's plug in 1/2. I'm going to just leave some blanks here, but we're going to put base 1 and base 2 in there, and then we'll put the height in this spot. Okay, so base 1 and base 2, that's the 20 and the 14. Stick them in there, and then we said it was 10 feet across to get that height. Okay, so let's calculate this. We've got 1/2, combine the bases to 34 and times by a 10 for the height. It's going to give me 170 square feet for trapezoid 1. Okay, trapezoid number 2 is going to be pretty similar. Oops, make that trapezoid 1 up there. I'm looking for 1/2, my bases added together, and my height. So on this one, I've got still a 14-foot base. This was 20 feet, just carried over from the other length. So again, it's 20 and 14. Now you might be tempted to just say this height is 10, but don't fall victim to that. You need to figure out this height. That might not be 10. In fact, it's not. We have 10 here. We have, if I steal this from up here, this is 20 in the middle section, but the total's got to be 36. So you already have 10 and 20. You already have 30 of it. There's only 6 feet left, and that's what your height is for this trapezoid. We're going to put a 6 in there. Okay, so calculating now, we've got half of 34 times by 6. And that makes a total of 102 square feet for that other trapezoid. Okay, so now all we have left to do is the rectangle, and we can add these up. Now the rectangle in here, that's a 20 foot by 20 foot, so just 20 times 20. I'll do it right on the inside. This is 400 square feet inside. Okay, so let's add them up. Trapezoid 1 was 170. Trapezoid 2 was 102, and then our inner rectangle was 400 for a grand total of 672 square feet of area. That sounds like a nice deck to me. Boy, I'm excited for summer. Okay, let's wrap this up with a word problem. Now, don't be scared of the word problems. You just got to draw a picture, so read it carefully. It's number 1, it's a trapezoid, and it's got an area of 50 square centimeters. So let's just note that. Area is 50 square centimeters, and let's just draw ourselves a trapezoid. No big deal. Reading on, one base is 2 centimeters, and the height is 5 centimeters. So it's not to scale, that's okay. We'll put 2 centimeters on our base, and draw in a height, of course mark the right angle, and then that's 5 centimeters. And our question, find the length of the other base. So let's just call this base 2 right here. All right, we can do this. First, the formula. Area is half of base 1 plus base 2. Say it out loud. Times by height. You do have to memorize these formulas, so if you say them out loud as you write them, you'll start to memorize them. All right, plugging in, we have the area. We know it's 50, and we are going to just start copying down. Base 1, that's our 2. Base 2, we didn't know, and our height here is 5. Okay, so there's a couple of ways we can solve this. I think that a lot of people would probably start by just timesing both sides by 2 to get rid of that half. So let's just double both sides, and that'll cancel my half and bring me to 100 equal to 2 plus base 2, still in parentheses, times by the 5. Okay, I say we divide by 5 to get rid of that times by 5 on both sides, of course. So now we're down to 20, and these just cancel. 20 is equal to 2 plus base 2. Okay, just subtract 2 and you're done. Base 2 by itself would be 18 centimeters. Okay, so we can put that in our picture. We can check it out. It's all good.